Today we're going to review the distributive property, and in particular the way that it plays into solving equations. We'll also pay some special attention to how the fraction destroyer works when parentheses are involved. So, you may recall that the distributive property is defined as A times the quantity of B plus C will always equal A times B plus A times C. And that sort of relates to the problem we talked about in class today, where if two kids are going to the movies and tickets are $12 and popcorn is $6, then you could either think of it as two kids getting each getting a ticket and some popcorn, or else that's the same as two tickets and two popcorn. We practiced this a lot last year, so I bet you already have your chops down when it comes to the distributive property. But let's look at how that plays out in some equations. Here's a really simple one. If I say 3 times x minus 7 is equal to 27, clearly all of these numbers are involved in the getting rid of parentheses step. When we distribute 3 over each of these terms, we get 3x minus 21 is equal to 27. Then add 21, and I find out that 3x is equal to 48, and that makes x equal to 16. Sometimes there are more steps involved. For example, if I have x plus 4 times x plus 6, close my parentheses, is equal to negative 1. Okay, so this has more steps plus some negative numbers. One thing that's important to recognize is that these are the numbers involved in getting rid of parentheses, so I just bring this down. When I distribute the 4, and it is positive because the sign in front of 4 is positive, positive 4 times x is 4x, positive 4 times 6 is 24, equaling negative 1. Combine these, and I get 5x plus 24 is equal to negative 1. When I subtract 24, I get 5x is equal to negative 25. And finally, x is equal to negative 5. Just one more basic one like that. We have a negative sign in front of the parentheses. So if I say negative 9 minus 3 times 2x minus 1 is equal to negative 18. Now, these are the terms involved with getting rid of the parentheses, not negative 9. I bring that straight down. Now what I'm distributing over the terms inside the parentheses is negative 3. Negative 3 times positive 2x is negative 6x. Negative 3 times negative 1 is positive 4, equaling negative 18. My like terms are negative 9 and positive 4. So negative 6x, notice it's negative because that's still a minus sign in front, minus 5 is equal to negative 18. I add 5. I've got unlike signs, subtract, use the sign of the greater, negative 6x. Oh, darn it. I see my mistake. This is negative 3 times negative 1 is positive 3, Mary. Okay, so then when I combine these, I find out that that is negative 6. It's always a problem if you are going a little too fast. So negative 6, come on, erase. Okay, I can't get it to erase, so we are going to just write over it. Negative 6, which means I'm adding 6, which means I'm adding 6. And that makes this negative 12 divided by negative 6 x is equal to positive 2. Hey, so it's always important to make sure you take your time. I just was a good illustration of that fact. Now the next thing that actually comes up is problems where we have fractions. For example, if I say, let's see, 3/4 times x minus 5 is equal to, I'm just going to make this up. I don't know if it's going to go in or not. It might not come out to be a whole number. But you can see that what we've been doing here is using the fraction destroyer first to get rid of fractions. The same thing happens here. I want to multiply the entire equation by 4. But what happens here is that these parentheses almost act as a protective shield. And you can see what I mean. I'll first show you this just to remember. This is what you need to remember. It doesn't affect what's inside the parentheses. Then I'll explain why that's true. But the main thing I want you to understand is that it doesn't, when I multiply this whole equation by 4, it doesn't hit the inside of the parentheses. It does destroy the fraction, making it 3 times x minus 5 is equal to 4 times 12, which is 48. Now, when I get rid of parentheses, I have 3x minus 15 is equal to 48. I add 15, and I get 3x is equal to, it does go in, 63. And when I divide by 3, I get x is equal to 21. So, protective shield. Now I'm going to explain to you the reason behind it. What I'm really multiplying is 4 times 3/4 times a number. We now know that x is 21. So 21 minus 5 is 16. This is what I'm really multiplying together. If I multiply 3 numbers in a row, just like make it easy, 2 times 3 times 4, I first do this, and then I do the other. Same thing here. 4 times 3/4 is 3, and 3 times 16 is 48. I don't touch the 16 until these two have been multiplied together. I want to show you what happens when it is a negative fraction, especially if it's like a negative 1/3 times x plus 4 is equal to, I don't know, 20. So I know I want to multiply by 3. If I multiply by positive 3, let's realize that what gets destroyed is just the 3. I still have negative 1 times x plus 4 is equal to 60. And that makes this negative x minus 4 is equal to 60. When I add the 4, I get the opposite of x is 64. Therefore, x is negative 64. That's one way you can do it. Most kids, however, prefer to multiply by a negative the first time around. Let's look and see what that looks like. The problem was negative 1/3 times x plus 4 is equal to, oh geez, now I forget what it was. I think it was 60. Okay, so if I multiply by negative 3, I've gotten rid of everything, and I just have x plus 4 is 60. When I subtract 4, okay, that wasn't the same problem, sorry. But anyway, you get the idea. If you multiply by the negative, then a negative times a negative is a positive. And that makes this positive 1 here, and that's when I get rid of the parentheses, it's the same thing. So this is 56. So, good luck with your homework tonight, and that's all for today.